Good afternoon, I'm Andy Stevens from BT Group. I'm Solution Architect in the TV team, and I've also just joined the DTG Council there. I'd like to spend just a few minutes today just to talk about what we're doing in the TV space, where we're trying to understand how much traffic this is going to be moving from DTG to OTT, and also how that traffic is likely to change in terms of characteristics. So, over the last 6 years, we've been tracking our broadband usage. We've been looking at live events and how those affect our network, and we can see that there's clear correlations and peaks in where we have football matches appearing on stage, on the screen. We also see troughs where the content is appearing on terrestrial TV and not on the network. Obviously, if you're scaling for peak, you're putting out a lot of equipment out there which is redundant most of the time, doing nothing. We'd like to try to smooth that as possible. Today's peaks, as we see them, are far in excess of average bandwidth, and we're expecting the migration from DTT towards OTT to accentuate these. There's a lot of reasons to do this. Financial, obviously, is the main one. Ecological, also a huge benefit if we can reduce the power consumption of streaming. So how much data are we talking about? 375 terabits. This is our national working assumption for the amount of peak traffic from DTT going to OTT. This assumes current usage patterns that we see today, and it assumes that the most popular channels will have migrated to UHD in this time. This is a monster that we need to work around, but we believe that we can potentially deduplicate a lot of this traffic. I'd like to speak about MAUD. MAUD is our Multicast assisted Unicast delivery. This is our way of taking any third-party traffic and deduplicating it within our network, using Multicast as the driving force behind this. MAUD requires no changes to the client player. It requires a very lightweight CDN integration for the purposes of maintaining transactional logging and for gaining access to the content. We also require a very lightweight integration on the content provider side, where they would effectively encode their original CDN URL with a MAUD prefix. That is all that is required to make MAUD run. The way MAUD works is very simple. We have an edge proxy code running deep within our network, in our case likely running on the home gateways in people's homes. The player will establish its request directly to the home gateway, which will split that request into two parts. One part is a header request, which will go to the CDN, requiring just the very lightweight response. The payload coming back would actually be sourced by Multicast. The home gateway then stitches those both together and delivers them to the client device in a way that the client device cannot tell. I'd also like to speak about our work on low latency encoding. In conjunction with the IBC, we were working on an accelerator program to do low latency encoding at scale. This was using RT's own content. It was a very stripped down delivery infrastructure where essentially the production truck would be sending direct to home, doing the origination of the content with CDNs in the middle. There was ad insertion in there, the full works. A core part of this was low latency L3D dash. This is important because this changes the request structures that we will see in the CDN. Going from traditional segments of 2 seconds to 10 seconds, with L3D dash, we're seeing request rates going down as low as 120 milliseconds. So this is a key dynamic that we will have to accommodate as we move towards low latency in the future. The final part I'd like to talk about is congestion control. Historically, we had an ABR bitrate ladder. We have transport mechanisms on top of that, HTTPS and QUIC, and typically you'd be running maybe active queue management on the application layer. These all work completely independently, and there's no collaboration between them. We're seeing more complexity as we're adding more transport layers, such as Medio QUIC and Amazon Psi, and we're seeing congestion control appearing in the appliance layer as well with L4S. We have initially been doing work looking at both QUIC and ABR, the ABR ladder, and if we can align those two together such that the quick congestion response coming from the server is mapped to the bit rates of the actual content itself. This allows us to give a paced throughput rather than the incredibly spiky throughput you would normally associate with TCP on this content. This, we believe, will allow us to establish a much smoother transition through the network, and will allow it to play a little bit nicer with all the different congestion control layers that are being mixed together in a way that is not possible to prepare for. And that's it from me. Thank you very much for your time.